Solve an equation with one radical. Um, in both of these examples, we have equations in which there is one square root symbol. When we have something like this, what we want to do is try to get the square root by itself on one side. So that we can then square both sides of the equation. By squaring the left-hand side, it's going to get rid of that square root symbol. And now I have a simple equation that I know how to solve. I'll add 1 to both sides. So 3x is equal to 5, and then I'll divide both sides by 3. And so I'm getting that x is equal to 5/3. When I square both sides of an equation, sometimes it creates solutions that are potentially not true. And so when I get an answer, I need to check in the as my final answer to make sure that it actually works. So let's go back to the original and let's check our answer. So I have a 3, and I'm going to multiply 5/3 in the place of x. And I want to know if that's equal to 0. The 3 times the 5/3 is going to be 5. And then I get the square root of 4 minus 2. And it looks like I am getting 2 minus 2, which equals 0. So this works out. So 5/3 is our answer. Let's do that process again with example B. Everything is away from the square root for this example, so I can start by just squaring both sides of this equation to start. So I'm going to square the left side and then also square the right side. On the left-hand side, the square root and the square symbol will counterbalance each other, so that square root symbol goes away. On the right-hand side, I need to remember to multiply this out using a FOIL method, so I'll end up with a 9. A 9x squared minus, I multiply these two terms together and double them, so that'll be minus 6x and then plus 1. So just to remind you, I'm doing 3x minus 1 times 3x minus 1. When I look at all the terms that are left, I have a quadratic. I have something raised to the second power. And so the strategy is always to get everything onto one side and 0 onto the other so that we can use one of our other methods to solve. So I'm going to move this 3 over. It's going to become a negative 3 over here, right? I'm going to subtract 3 from both sides. And I'm also going to move the x by subtracting x from both sides. I want to end up with 0 over here on the left-hand side. So it looks like I'll have 9x squared minus 7x minus 2 is equal to 0. All right, so let's factor. We want to take 9 and negative 2 and multiply them together. So that'll give us a negative 18. And then we want to think about the factors that we can multiply together to get 18. One of them needs to be positive and one of them needs to be negative. So it looks like to get 7 in the middle, I want to go with the 2 and the 9. I want the 9 to be negative. I want to have a plus 2x and a minus 9x. So I'll split the middle term. I'm going to put the 9x here, so it'll be next to the 9. It doesn't matter how you split the middle term up, but I'm just kind of putting this together. It'll make the factoring a little bit easier. All right, now I'm going to look at the first two terms together and the second two terms together. 9x squared and 9x have a 9x in common that can come out to the front, and I'll be left with x minus 1. I want my second set of parentheses to match, so I'll put an x minus 1, and it looks like I would put a plus 2 here. I just like to always check. That'll give me plus 2x minus 2. Yeah, that works. So I'm getting 9x plus 2 and x minus 1 equal to 0. So 9x plus 2 equals 0, or x minus 1 is equal to 0. Let's subtract 2. 9x equals negative 2. Divide by 9. So x is equal to negative 2/9 is one of our options. For the other option, we're getting x is equal to 1. Now, before we claim these as our answers, we need to go back and check in the original to make sure that they actually work. Because sometimes when we square square roots, what happens is we're making everything positive. And so sometimes there are extraneous solutions that show up, solutions that don't actually work in the original. So our original was x plus 3 in square root equals 3x minus 1. This was our original equation. Let's start with the 1 because it's easier to plug in. Let's check x equals 1. So I'll have, I'm replacing x with 1. We want to know if this is true. The square root of 4 is equal to 3 minus 1. Yes, we're getting 2 is equal to 2, so that one works. So over here, I'm going to put a box around this. We know that x equals 1 does work. So now let's check x equals negative 2 over 9. So I'm plugging in 2 over 9 in the place of x on both sides of the equation. I'm going to grab the calculator here, and I'm going to do negative 2 over 9 plus 3, and what I'm getting is 25 over 9. And then 3 times negative 2 over 9 is negative 2/3. The square root of 25 over 9 is 5/3. I can take the square root of the numerator and the denominator separately. But on the left side, when I take that negative 2/3 and I subtract 1, I'm getting a negative 5/3. These are not equal to each other. So we're going to reject this answer. This is an answer that we got artificially by squaring both sides of the equation. The next set of examples are similar to what we just did, but now what we're doing is we're looking at equations that have two radical symbols in them. And so when we have something like this, we end up needing to square the both sides of the equation actually twice. Before we get started, what we want to do is we want to move the square roots onto opposite sides of the equal sign. So I will start by adding the square root of x plus 2 to both sides. So we'll have the square root of 2x plus 3 equaling 2 plus the square root of x plus 2. We want to make sure that square root symbol goes all the way over both terms. All right. Now what we'll do is, now that we've put one square root on each side, we will square both sides of this equation. The left-hand side is going to be easier because this is just going to get rid of that square root symbol. But on the left-hand side, we need to think about FOILing this out. So this whole thing gets multiplied by this whole thing. For our first terms, we're going to take 2 times 2, so that'll be 4. For the outer and inner terms, we're going to have the same thing multiplied together, and we have 2 of them. So I'm going to end up with plus 4 times the square root of x plus 2. And then we'll take our last terms, and that'll end up being square root of x plus 2 times the square root of x plus 2. Those are going to those square roots will counteract each other, and we'll end up with just an x plus 2. All right, so I've got a lot going on. What I'm going to do, let's simplify the left-hand side first. I've got x plus 6, I mean the right-hand side, plus 4 square root x plus 2 equals 2x plus 3. Let's subtract x and subtract 6 from both sides. We want to move everything away from that square root that's left. So this will be x minus 3, and then 4 times the square root of x plus 2. So now I'm back to the types of problems I was doing just a minute ago, where I'm going to square this whole equation again to get rid of the square root symbol. There's a 4 sitting here, and sometimes people like to divide out by that, but if I do that, it's just going to create fractions over on the left, and I don't really want to deal with fractions. So let's instead just, at this point, square both sides of this equation. So this will be x squared minus 6x plus 9. And when I square the right, I have to square the 4. It's going to be 4 squared will give me 16. And then I'll also square the x plus 2 under the square root. That'll change to x plus 2. All right. Now I have a bunch of terms that we want to collect onto one side of the equal sign. So let's subtract 16x and subtract 32. So I have x squared minus 22x minus 32 plus 9 minus 23 equals 0. So this can factor into x minus 23 and x plus 1. So x minus 23 is 0, or x plus 1 is 0. So we're getting x is 23 for one possible solution, and x is -1 for another possible solution. Before we decide if these are our answers, we have to go back and check with the original. So let's copy the original down over here. It was 2x plus 3 minus x plus 2 equals 2. We're going to check our answers. All right, so let's check x equals 23. So I'm going to have 2 times 23 plus 3 minus 23 plus 2, and I want to know if that's equal to 2. 2 times 23, that's 46. And then this is 25. This is the square root of 49. minus 5. We're getting 7 minus 5 equals 2. This works. So yes, x equals 23 is in fact one of our solutions. All right, let's check x equals negative 1. Let's see. I'm getting negative 2 plus 3. And then I'm getting negative 1 plus 2 is just a 1. I want to know if this is true. Square root of 1 minus the square root of 1 is 0, not 2. So it looks like that answer does not work. This one we reject. So our only answer for this is x equals 23. All right, let's do one more example like this. These are lengthy. Our first step is to move this square root over to the other side. So we'll subtract that from both sides. So I'll end up with 1 minus the square root of x plus 2. The next step is to square both sides of the equation. And then on the left, that square root symbol goes away. On the right, we square the first term. We multiply the two terms together and double, so that'll be minus 2 times the square root of x plus 2. And then we square the last term. So that'll be plus x plus 2. Okay. So simplifying the right-hand side a little bit, if I bring these over into the front here, I'll have x plus 3 minus 2 times x plus 2. And then I want to bring those terms over to the left-hand side. So I'm going to subtract x and subtract 3 from both sides to get 2x plus 4 equals negative 2 times the square root of x plus 2. In the last example, when we got to this step, we didn't get rid of that number that's in front of the square root, but in this case, if we divide both sides by a negative 2, it's not going to create fractions, so I think I'll do it at this point. So we'll have negative x minus 2 and then x plus 2 in the square root. So I had to divide the negative 2 into this term, and then I also had to divide it into this term. All right, so now we start over again, and we square both sides of this equation. On the left-hand side, we're going to square the first term. Negative x times negative x is x squared. I multiply the two terms together and double them. So those multiplied together are 2x, and if I double that, I'll have a plus 4x. And then I square the last term, which is plus 4. And then I have x plus 2 on the right-hand side. The square root and the square cancel each other out. Let's move everything to the left-hand side so that we can solve this quadratic. X squared minus 3x plus 2 equals 0. And this factors into x plus 1, x plus 2. No, this should be a plus. Let's pause for a second here. Let's just go back and double check. Yes, this was a positive 3x plus 1 plus 2. Okay, good. We're back on track. All right, equals 0. So I'm getting that x plus 1 equals 0 or x plus 2 equals 0. So then x is -1 or x is -2. All right, let's go back and check our answers. Let's see. X is equal to -1 was one of our answers. So let's plug in -1 for x. So -3 plus 7 is the square root of 4, or 2. And then this is the square root of 1, so plus 1 equals 1. That doesn't look like that's going to work. 3 does not equal 1. So we think that maybe -1 is not a solution. Let's check x equals -2. So now I'm plugging -2 in for x. So I'm getting -6 plus 7 plus, this is a square root of 0. Square root of 1 plus 0 equals 1. Yes, this is true. 1 equals 1. So it looks like x equals -2 is our only solution here. Again, when we square something, we create everything into positive numbers, and so sometimes we have what are called extraneous solutions, solutions that are not true. So it's very important that we check our answers to make sure that they work with the original equation that we were given.